Good morning, friends. Welcome back to the class. I hope you all are safe and healthy too after long back. So it's an again opportunity to serve you. Right. So in this session, we are begin with the new chapter, that is chapter number 7, that is integrals. So first we need to understand what is meant by integrals and what is the use of integrals in the calculus and what is the emerge of this chapter, right? So first of all, what is meant by integrals? So before introducing integral, you need to just recall the derivative of some particular formulas. Let us say the derivative of the x is a variable, we'll say 1. So now 1 is called derivative, right? So if f of x is equal to x, then f dash x is equal to 1. So if f of x is given, you are able to find its derivative by using some formulas or by some techniques. Now, if the derivative is given to you, are you able to find the function? That's a question. It means if you are given the derivative of particular function, are you able to find its original function? It's completely reverse process. So the reverse process of what to find the parenting function or original function is called antiderivative. Antiderivative, the process of finding the original function where you know that the derivative of the function, right? So the process of finding the original function from its derivative is called antiderivative. The antiderivative is also known as integration, as simple as that. So this integration, or you can also speak like antiderivative, is the basic fundamental is to what? To find the parenting function. But if you try to understand in the broad terms, the integration, the process of finding the parenting function, right? So this integration is broadly divided into two parts. One is indefinite integrals, and definite integrals. There are two parts. The definite integral is to what? Find the bounded area. Find the bounded area, approximate area. Let us say there are two parabolas drawn such a way, and you want to find the area bounded by these two curves. And since we don't have a specific formula for that, so we need some technique, and that technique is basically uh, fulfilled by the definite integrals. So definite integrals are basically used to find the bounded area between the two or more than two curves, right? And the indefinite integral is to what? Find the parenting function, that is the original function. Original function. So here integrals are serving two different purposes. One is to what? To find the original function when you have given the derivative of that function. Second is to what? To find the bounded region. So this is the our syllabus which we are having in a 12th standard. So in this chapter we will study how to find, how to deal with indefinite and how to deal with definite, and you will going to find the bounded area between the curves under the chapter application of integrals. So this is all about the integration. Now we are coming to one more point before we actually get into the sums. Okay. Now just I am taking the help of derivative again to speak the second point. Derivative of 2x, derivative of, sorry, derivative of x square is what? 2x, right? So in this manner, if it is a function, it is a derivative. Then antiderivative of 2x, what I'm speaking, antiderivative of 2x is x square, right? So instead of writing antiderivative, we can also speak like integration of 2x is x square, and symbolically we are writing this just a symbol we are using to represent integrals. Integral of 2x, and we have differentiated this function with respect to x. That's why this also integrated with respect to x. So integration of 2x is x square. So I think instead of speaking here antiderivative, it is better to speak integral of 2x is x square. Now I am taking the next here connected to this one. Derivative of x square plus 1 will also give 2x. Hence, integral of 2x with respect to dx is also termed as x square plus 1. Now, if I take the derivative of x square minus 2, still the derivative answer is 2x. Hence, integral of 2x dx will be x square minus 1. Are you getting me? So, hence, what I am speaking, when you are talking about the derivative of a function, you are getting the same answers. But when you talk about integration of 2x, integration of 2x, integration of 2x, you are getting various answers. See here. And these all answers are differ by a constant. See, I can write plus 0 here. Here you are getting 1, here you are getting minus 1. So what these constants are, basically arbitrary constants. These constants are called arbitrary constants, also known as constant of integration. So whether you are dealing with the antiderivative or integrals, when you are doing the integral of any function, you may get infinitely many answers depending on the constant involved. And that's why what we are writing is, when you are doing the integration of 2x answer, what we are writing? In short, x square plus c, where c is any real number. So this is the way of expressing the integral answer. It means whenever you are doing the integration of any function, whatever the answer is going to happen, you have to write plus c. That is what c is any arbitrary constant. It may belongs to any real number, right? So here the answers are indefinite, are infinite. That's why this type of integrals known as indefinite integrals. Indefinite means we don't know what is the actual integral function. Okay, what is the actual original function? So C may take any real value, so it may give infinitely many answers, it may give infinitely many original functions, but all these functions are of same nature. Let us say, यहाँ देखिए first answer x square, it's still representing x square function is quadratic, right? Where it will give the parabola. X square plus 1, still this answer also quadratic, hence it also representing parabola. So x square minus 1 will also give what? Integral, that is what? A quadratic, which also gives the parabola. So they, though you are getting a various answers, but all these answers are all these integral values representing the same curve, same curve, just they are different by the constant. Okay, so that's why the constant is various. According to the constant, you may get infinitely many values, infinitely many curves, but these all curves will be parallel to each other. So finally, what I wanted to convey is whatever the answers you are getting as an integral, it always gives the family of curves, and this family of curves are always parallel to each other, parallel to each other. So this derives, this speaks the geometrical meaning of indefinite integral. So indefinite integral geometrically representing that family of curves differ by the constant and they are parallel to each other. So when you are doing the integral of 2x, it will give the x square plus c. It means that it serves the family of parabolas, right? That all parabolas are parallel to each other. So here, just for your reference, I am just drawing the like this. So integral answer always giving the family of curves. It may be a circle, it may be a straight line, it may be a parabola, it may be a ellipse. But it always give a family. It means a group of curves. So if you are assigning a value to the C, it will give the member of that family. Let us say it is at origin. The second curve is at origin. This will be x square and this will be x square plus 1. This will be x square minus 1. This will be x square minus 2. This will be x square minus 3. All are parabolas. It's only differ by the constant. So if you select a constant, if you assign some constant or fixed value to the C, then you are getting a member of this family. Member of this family. If you are not specifying a number here, it means it serves any constant or any real number. Hence, it will give a group of curves and which are always parallel to each other. I hope now you have understand the meaning of indefinite integrals. Why it is called indefinite? The point number one, whatever the answer you are going to get, that always includes a constant which we called as arbitrary constant. You have to write plus c always in the integral answer. That's why it's called indefinite. And what it geometrically serving? Geometrically it gives a family of curves which are parallel to each other. Only they are differ by constant. If you assign a constant, it will give the member of that family. That's all. It may give member of family of straight lines, family of ellipse, family of parabola, family of circles, family of any curves, right? So this is all about the indefinite integral. Now the point is how to solve the indefinite integrals. For that, you need to remember the derivative formulas. Just reverse that formulas to get inverse one. So let's have some discussion on the formulas first, and then we'll go for the methods to find out the integrals. Right. The first one I'm speaking about. See the derivative of x to the power of n plus 1 by n plus 1, right, is what? अगर हम इसको डेरिवेटिव करेंगे you will get x to the power of n. So therefore, integral of x power n, if this is a function, its derivative is this. So integral of this value, x to the power of n, with respect to dx will give as x to the power of n plus 1 by n plus 1 plus c. This is always you need to write, and here you are also specifying c is any real number. Now, in a similar manner, you may also speak the derivative of a variable x is 1. Therefore, integral of any constant 1 will give x, because with respect to x it will be x, with respect to y it will give y. Okay. But you are dealing with indefinite integrals, it must have a constant c, and you know why we are adding this. In similar manner, you may also speak like derivative of e power x serve as e power x. So integration of e power x dx will also give e power x plus c. In a similar manner, now you have understood how the formulas of integrals are coming. So I'm directly writing few important formulas of that. So integration of a to the power of x dx, where a is any constant except e here. So a power x upon log a plus c. So these are the fundamental formulas you can speak, right? So ये आपको most importantly सर्व करेंगे जब आप algebra questions करेंगे. So integration of x to the power of n is what? X to the power of n plus 1 by n plus 1. Integration of any constant, let us say 1. So 1 का integration x होगा. अगर 1 की जगह मान लीजिए integration of k is any constant, then answer would be k can be written as a constant, or you can take it as outside of the integral. Also you can write kx plus c, because अगर हम k को बाहर रख देंगे तो कोएफिशिएंट 1 बचेगा. 1 का इंटीग्रेशन x होगा, hence therefore integration of k will be what? Kx plus c. In a similar manner, integration of like sin x dx will be what? है ना, जैसे कि आप बोलते हैं कि cos x का डिफरेंशिएशन माइनस sin x, तो sin x का इंटीग्रेशन माइनस cos x plus c, and integration of cos x will be what? Sin x plus c. So in this manner, the list of formulas are given in the beginning of the chapter. So I will suggest you people to just go through that formulas first and then apply those formulas to begin with this chapter. Okay. So I think it is on the page number 196 in the NCERT textbook. The list of formulas are there. Just refer that page to get into that knowledge. So with the help of these fundamental formulas, now we'll proceed further. So in the now the main chapter is dealing with indefinite. So our chapter is the indefinite integral chapter is divided into indefinite and definite. So the first portion in coming sessions also we are going to discuss only indefinite first. Once we finish that, and then we'll get into definite one. To solve the indefinite of integrals, there are various techniques available. Just like in derivatives, we were having product rule, right? As well as quotient rule, chain rule, and thereafter we move to the substitution technique where inverse trigonometric functions are involved, and then we move to the parametric form, and then we move to the logarithmic differentiation, and then we move to the double differentiation, like that. So various techniques are involved just to simplify the integral of various functions. So the major, you can say the entire indefinite integrals are dealt with four major things. One is the direct method, which we called as direct method, also known as inspection. Means just by observing the question, right, you can solve the integrals, and by using the fundamental formulas. Second is what? Substitution method, right? We will discuss in the next session. Then partial fractions, then integration by parts. So if you divide the indefinite, there are basically four techniques, four different techniques to deal with this chapter. So first, today in this session, we're going to understand how we can solve the integrals by inspection, or we can also say by direct method. Okay, so the first exercise that from the NCERT, the first exercise 7.1 is completely based on the inspection method, or we can also say by direct method. So by direct method, we can solve the integrals. It's so easy and simple and boosting concept. So from this exercise, to understand more, I will take only 4 to 5 sums to get the proper idea about the direct method of integrals, and rest you can complete from your side. So first, I'm taking the questions like integration of, uh, let us say the question is question number 11. I'm taking integral of x cube plus 5x square minus 4 upon x square dx. Okay, so this is the question. Okay, now what I'm speaking here, you cannot find directly here, but by doing some small modification, जो general techniques होते हैं, since it's a monomial, it is possible. See, अगर denominator में monomial होगा, यानी single term होगा, the best way is to what? By using this separate the fraction. अब जैसे इसको separate करेंगे, what the question is going to be. So let I stands for integral. So always start with like let I is equal to question. Then I is equal to, just separate the denominator. So x cube by x square plus 5x square by x square minus 4 by x square. Now you can simply cut these values here. X will left. You can shift this x square into what? In the numerator. So hence this integral is now can be separated like x into dx plus 5. Since phi is a constant, I can keep outside and the coefficient is 1 is left into dx. Minus, since 4 is a constant, I can keep outside. So 1 by x square can written as x to the power of minus 2 into dx. Now you can see this entire complicated function is converted into three simplest one. And as you know, the formula of integral of x to the power of n dx is x to the power of n plus 1 by n plus 1 plus c. Right? So by using this single formula, I will be able to solve all that. Now here the power is 1, so its integral value is n plus 1 by n plus 1, hence it will be x square by 2. I can also write plus c in each part, but it creates a lot of what we call as confusion. So at the end only, after completing the entire sum, I will write c once instead of writing 3 or 4 times. Okay, right. Next, 5 into integral of 1, the constant 1 is x, and here if you apply the formula n is minus 2, so if you apply this formula you will get x to the power of minus 1 by minus 1 plus c. This is applicable for entire function. Now just simplify one more step to complete the answer. So I is equal to x square by 2 plus 5x plus 4 by x plus c. That's it. So this is the way to solve what, just by inspection. Inspection means by direct method, just by simplifying a given function into simplest format where you can apply the fundamental formulas to simplify further. So I'm taking few more questions where you can apply this. Yeah. I'm taking now the question number 13. Okay. Yeah, question number 12. Better to take question number 12 first and then we'll come to that. Here, under root of x into 3x square plus 2x plus 3 into dx. Now you can see again it's a complicated sum looks like, but when you simplify further, when you take this integration inside, when you distribute it, it will convert into a small integral questions. So what I will do first, I will multiply this root x with this trinomial. There are three terms multiplied with the term, and then I can use the exponents here to get the single one. So when root x is multiplied by x square, their powers are added, it becomes what? 3x to the power of 2 plus 1 by 2. For your convenience, I will write first the multiplication step. 3x square into root x dx plus integral of 2x into root x dx plus integral of 3 into root x dx. This is I equal to. Now keep the constant outside, and root x means x to the power of 1 by 2, and since they are in the product their powers are added. So 2 plus 1 by 2 is what? 5 by 2 into dx. Since here 2 is a constant, keep outside and then add the powers. 1 plus 1 by 2 is 3 by 2 dx. 3, since constant, keep outside, since we are left with x to the power of 1 by 2 dx. Now you can use a formula of integral of x to the power of n, that is x to the power of n plus 1 by n plus 1. So if you use that, you are going to get as 3 times of x to the power of 7 by 2 by 7 by 2 plus 2 times of x to the power of 5 by 2 by 5 by 2 plus 3 times of x to the power of 3 by 2 by 3 by 2 plus c. Now when you reverse these fractions, you are going to get the final answer, right? So the answer is here 6 upon 7 x to the power of 7 by 2, and if you reverse that one, 4 upon 5 x to the power of 5 by 2, and here you can also speak like 3 cut, and it will be 2 times of x to the power of 3 by 2 plus c. So this is about the integral answer. I think it is so simple. So in this manner you can proceed with. Now just to understand more, again I am taking a few more questions where you can do like this. Question number 13 I am taking here. integral of x cube minus x square plus x minus 1 by x minus 1 into dx. Now you can see again it's algebra. So if it is a binomial first of all, so you cannot separate like this directly. There is no use. You can do that one, but there is no use, right? So if you observe closely observe the numerator, it is factorizable. It is factorizable. See, from the first two terms, I can take x square as a common factor, and the next two terms I can take 1 as a common factor. So I is equal to, if I take x square as a common factor, what is left? X minus 1. And then here I can write 1 as a common factor, x minus 1. And denominator still same, carry on, dx. Now I is equal to, here from x minus 1 is a common factor, and we are left with only x square plus 1 by x minus 1 dx. So if I'm doing this, so x minus 1 get cancelled as a common factor. Hence, we here x square plus 1 dx. Now you can separate this integral as a subparts. Integral of x square dx plus integral of 1 into dx. So integral of x square is what? X cubed by 3. Integral of 1 is x plus c. Problem solved. So various टेक्निक्स यू कैन यूज जनरली जो हम लोग कई सालों से इसको सिंप्लीफाई करते आ रहे हैं, वही टेक्निक्स वही आपका आईक्यू यूज करें और इस तरीके से डायरेक्टली सॉल्व हो जाएगा. वो कॉम्प्लिकेटेड क्वेश्चन सिंपलेस्ट क्वेश्चन में कन्वर्ट होगा एंड देन separate the integrals to solve. So I'm taking one more question here. Integration of root x plus 1 by root x the whole square dx. So simple as that. Again, it looks like a plus b whole square. Expand it and separate it and then solve. Next question probably about this is next question. So I is equal to, just open the identity, a square plus b square plus 2ab. So a square means x dx. Let us say x plus b square means 1 by x. 2ab मतलब 2 into root x into 1 by root x dx. So root x also get cancelled. So now you can separate the integral like x into dx, integration of 1 by x into dx, and 2 into integration of 1 dx. So integration of x is what? X square by 2. But 1 by x integration, if you are applying the formula like derivative of log x is what? 1 by x. So integration of 1 by x is what? Log x. It just reverse process as I told in the beginning. So 1 by x integration is log x and simply write log x. Then 2, 1 ka integration x plus c. This is your final answer. Over. So this is what we called as the direct method. So in this manner, you can apply your own IQ, right? For simplification process, you required identities, right? You required sometimes factorization, sometimes exponents, and by using the fundamental formulas of integrals, right? So just for your sake of convenience, I am taking one more sum here. Question number 18 I am taking. Integration of sec x into sec x plus tan x dx. Now, if you closely observe, it's a binomial. Just by doing the multiplication, you are going to get a fundamental function. Sec square x plus sec x into tan x. So you can separate the integrals as two parts, sec x into tan x and dx. Now just see what the here sec square x formula is tan x, because tan x derivative is sec square x, so sec square x integral is tan x in this reverse process, plus sec x tan x. It is basically the derivative of sec x, hence its integration is sec x, right? So hence the answer is tan x plus sec x over. It's so simple. If you understand the reverse process of derivative is called integration, nothing else. So the last sum I'm taking here in this session. So let us take the question number 20 I'm taking here. The integration of 2 minus 3 sin x upon cos square x dx. Now see, just since it's a monomial, I can simply first separate the fraction. So it will become about 2 by cos square x, also written as 2 sec square x, and integration of here 3. If you separate this, 1 sin x and 1 cos x is converted into tan x, into 1 cos x is left, that is reciprocal is what? Sec x, and dx by default left, right? And you can take this 2 outside, 3 outside. So when you do take these 2 outside, it become only sec square x. Sec square x integration is tan x. And sec x tan x integration, already we have used this formula here. 3 sec x plus the 4. So this is a so simple exercise, right? Wherever the direct method is applicable, just apply in this exercise to complete the chapter. Sorry, complete the exercise. So it's a beginning. So friends, I request, please do take care of each and every term, each and every concept, and don't forget to write dx in the each part of the integral, and don't forget to write plus c as a arbitrary constant in the end answer, because if you are not writing c, it termed as a definite integrals, and definite integrals and indefinite integrals are entirely different. They are serving two different purposes, so you need to understand the use of c while dealing with indefinite integrals. So here I am winding up this session. So I hope this session will very useful to you and definitely help you to begin with the integral chapter. So best of luck and take care, and bye bye, and see you will meet in the next session with the next technique that we called as substitution technique, which will be served to solve various functions which are basically a composition functions, right? So wherever the composition functions are coming, we'll use the substitution technique, and that we will discuss in the next session in some more details. तब तक के लिए आप लोग देखते रहिए, समझते रहिए और सीखते रहिए और पढ़ते रहिए और एक्सपर्ट बनते रहिए. Thank you all of you for watching this video.